Hello everyone, welcome back to my new video. In this video, we're going to learn unit testing in Android. Before jump right into this video, there was a small update for my YouTube channel. The last video uploaded in my YouTube channel was 9 months ago. I does not post any upcoming videos in between this duration. This is because I am rather focusing on uploading articles and contributing projects on GitHub because creating video and uploading is YouTube is a painful job. We need to edit and then upload. This takes a lot of time. If this video has a reasonable support, I try to make videos frequently on a YouTube. Let's jump right in the video. Testing is a crucial part in programming. It is also in a case in Android. Test can verify the behavior of our application work as expected. If you break something in your code, it immediately reports the problem or a failure. We will easily fix that issue in early development stage without actually ship our application to production. As you can ask me, why we need a testing framework like JUnit to test our application. So far, we test our application manually by clicking those buttons and start interacting with views. This is a manual approach. It is not very scalable. If you add a new feature in our application, we need to test again the new feature that works as expected as before. This is not scalable approach. We need to automate our test. There are multiple testing frameworks for Java. The most and well-known and the default in Android is JUnit. It runs our tests repeatedly and fastly compared to manual approach. Testing scope. Testing scope determines where our test touches the code. Automated tests are divided into three categories: unit test, integration test, end-to-end test. Unit test are covers very small portion of app. It can be single class or a single method in that class. Integration test. This tests the interaction of one or more units to make sure they are behave work as expected. They are test larger scope than unit test. It can be run either locally or instrumented test. End-to-end test covers large portion of an app. Example, whole screen or a user journey. It has a higher fidelity rate. Higher fidelity rate. Fidelity rate typically determines how our test is close to real world production. It also comes with the cost of higher test execution time. We need to some balance somewhere in between. Types of tests. Tests are classified based on whether they are run. In Android, there are two tests: local test and instrumented test. Local tests run on local JVM on host development machine. So it really fast and typically include core logic such as business logic, mathematical calculation. It does not need to interact with Android frameworks such as contacts and any other. So it has a lower fidelity rate. And instrumented test, it rely on Android devices. Either it can be physical or emulated. So it generally slow to run. Instrumented tests are typically UI tests. Example, testing the DAO in room database, it has a higher fidelity rate. In this video, we will learn how to write unit tests in Android. I opened my Android Studio. As you can see, there was a two sources named Android test and test. Android test folder contains our instrumented test that requires Android framework to execute. And this test also need an Android device to run. Example, our room database data access object method or go inside that class. And we have another source set named test. This folder contains our local unit test that does not need to interact with the Android framework, so it generally fast to run. I created two very simple classes for demonstrating unit testing: age checker and calculator. This class does not do much. This age checker class has a single check age function that returns a string based on the input age type of int. If the age is, will be greater than 1 or 2, it simply throws the illegal argument exception. Let's see how we handle exception in test cases. And we have a calculator class. This class has three methods: add, subtraction, and division. Just to do whatever the name implies. Let's test the age checker class first. Create a class in test folder. Because this class does not interact with the Android framework, this is a pure Kotlin logic. Right click the package, new Kotlin class or file. Name the class age checker. Let's create the object for the age checker class. Let's import this initialize function annotated as at the rate before. This means this function execute before the test cases. Best place for initializing the objects. Let's add our test case. I added this test case to check when we input the age 5, it should return child as expected value. That's true. When we enter age between 1 to 11, it should be child. That's we I expect in this function. Let's run this test. It will pass or fail. I hope this will pass. As you can see, this test will be passed. Let's write another test case to check this function that is actually returning an exception when the input age is greater than 1. I just add this function. As you can see, I use assert throws here because when our code that throws an exception, we need to use assert throws. When I input a age that is 120, it should return a illegal argument exception that I check here. I input a age 120. In this block, we need to execute that code that returns exception. I use the same exception that returns in this function, illegal argument exception. Let's test our code. This test case should be passed. This is because this function is actually returning an exception when the age is greater than 102. I also added test cases for calculator, named calculator test. As you can easily understand this code by reading, I created a 5 different test cases by passing different values. In this function, I pass 2 plus 2. That's simply add 2 plus 2. That returns 4. That's I check here. The expected value be 4. And same for this function 5 plus 3. Its expected value should be 8. And same for subtract function. And same for division. But here is the catch. I use division. When we divide our value with 0, it usually fails the exception, so-called arithmetic exception. I use assert throws used in previous example. This function is also passed because when we add any number with 0, it should pass. Let's test our whole class by clicking this icon. As you can see, 5 out of 5. Our all tests must pass successfully. So far we learned how to write unit tests for Android. If you want to know how to write unit tests for real application that is written based on MVVM architecture, I highly recommend you to check my articles on medium.com. In this article, I guide you through how to test view models and more. In this article, I use my sample note app. This note app is also published as open source project on GitHub. I link you those in this video description. I hope you will like this video. If so, don't forget to like and subscribe. And I see you in the next video.